Today we're going to look at transformations of functions. So we're going to start off by filling in these tables and graphing this function. It says complete the table values for each function. Use the table to graph the function on the coordinate plane. So this first one says f of x equals the absolute value of x. That's how you read that, absolute value. So we're going to use these x values and plug them into that function and see what we end up with. So for example, the first one you would read as the absolute value of -2, which is 2. So that's what we're going to fill in for our y. The next one would be the absolute value of -1, which is 1, which is what we're going to fill in for our y. The next one says the absolute value of 0, which is 0. The absolute value of 1, which is 1. And the last one is the absolute value of 2, which is 2. Now we're going to go down to this graph and plot those points. So the first point's -2, 2, so left 2 and up 2. -1, 1, so left 1 and up 1. 0, 0 right in the center. 1, 1, so right 1 and up 1. And 2, 2, so right 2 and up 2. Then we're going to connect, and notice you get this V shape. So now we're going to go over and we're going to look at this next one, which is the absolute value of x plus 2. We're going to plug in these. So we're going to have the absolute value of -2 plus 2. So the absolute value of -2 is 2, and 2 plus 2 will give us 4. The next one is the absolute value of -1 plus 2. So absolute value of -1 is 1. 1 plus 2 will give us 3. Absolute value of 0 is 0. Plus 2 will give us 2. Absolute value of 1 is 1. Plus 2 will give us 3. And then the absolute value of 2 is 2. Plus 2, which will give us 4. So now we're going to plot these. So left 2 and up 4. -1, 3. So left 1 and up 3. 0 and up 2. Right 1 and up 3. And right 2 and up 4. Connect. We still have this V shape. But now notice, between the first one and the second one, it looks like that V shape went up 2. So let's go over to this last one. So this last one we have the absolute value of -4 plus 2. So this time we're going to do what's inside first. So -4 plus 2 is -2, but the absolute value of -2 is 2. Then we're going to have the absolute value of -3 plus 2. We'll do what's inside first. So -3 plus 2 is -1. The absolute value of that is +1. Then we'll have the absolute value of -2 plus 2. So -2 plus 2 is 0. Absolute value of that is still 0. Then we'll have the absolute value of -1 plus 2. So inside, -1 plus 2 is 1. Absolute value of that is still 1. And then the last one, absolute value of 0 plus 2. So 0 plus 2 is 2. The absolute value of that is still 2. So plot your points. So -4, 2. So left 4 and up 2. -3. So left 3 and up 1. -2, 0, left 2 and at 0. -1, 1, so left 1 and up 1. And 0 and up 2. Connect, and you still have this V shape. Now notice how they all are similar because they're all V shapes, but this number here seemed to change the middle one and the last one. Notice on this middle one you had a +2 and we went up 2 from the original. Notice on this last one it looks like we moved left 2. These are called transformations, specifically translations, and this is what's always going to happen. So this is just a generic equation that shows you exactly what each number does. So I'm going to start here with number 2, this H. It says the number 2 is the horizontal translation. Notice it's the number that's inside the parentheses. So this number is going to tell you that you're either going to move left or right. And notice it says opposite. It's the opposite of whatever it looks like. Whereas this number 3, this number that's on the outside of it, whatever you're adding or subtracting from the outside of it, is going to move it up or down. Okay, up or down. And it's exactly as it seems. If you're adding, it's moving up. If you're subtracting, it's going down. So exactly as it seems. Whereas this number that's out in front is going to do one of two things. It's either going to make your graph really skinny, which is what happens if you have a number that's bigger than 1. Notice it says the absolute value is bigger than 1. It's going to make your graph skinny. But if that number's between 0 and 1, it's going to make it look wide. And if it's a negative number, it's going to flip the graph upside down. Okay, so we're going to look at some examples. It says, give the name of the parent function and describe the transformation represented. So notice how each one of these has this exponent of 2. That means that this is a quadratic function. This is a quadratic, okay, which is what you did in Math 11. So that means if you were to graph it, it's going to be a parabola, a U-shape. So let's look at example 1. We have x squared minus 2. So notice how we have this minus 2 out here. This minus 2 is going to take your graph and move it down 2. Which means if we were to look at the parent function, your vertex, that bottom point, would be right there in the center at 0, 0. But this minus 2 is going to move it down 2, which means your vertex is going to be down here at this negative 2 instead. If you look at this middle one, we have the quantity of x minus 2 squared. That minus 2 is inside the parenthesis. So this is going to take your graph and move it to the right 2. It's the opposite of what it seems. So that means the vertex is going to be over at 2 on the x-axis. This last one, this number 3, we have this minus 2 still, which we just said, inside the parentheses is going to move us right 2, but notice we have this negative out in front as well. So that means it's going to flip our graph upside down. So our vertex is going to be over here at 2, but our u is going to go upside down since we have that negative number. Okay, so several more examples here. So the one at the top says h of x equals the quantity of x minus 2 squared plus 1. So inside the parentheses is going to be left or right. Since this is a minus, you're actually going to go right 2. It's the opposite of what it seems like. So that's going to move it right 2. This plus 1 on the outside is going to move it up 1. So that means your vertex goes right 2 and up 1. So something like that. Okay, over here we have h of x equals the quantity of x plus 1 squared plus 2. So inside it's going to go left or right. So actually the opposite of what it seems. So this plus 1 is going to move that graph left 1. And the plus 2 on the outside is going to move it up 2. So your vertex is going to go left 1 and up 2. You're going to be up here. Okay, g of x equals 2 times the quantity of x plus 2 squared. So inside is left or right, the opposite. So this is going to move it left 2. The number out in front, since the absolute value of 2 is 2, since that's bigger than 1, that means it's going to make your graph skinny. So you're going to go to the left 2 for your vertex, and your graph is going to look skinnier than it normally would. This last one, we have the g of x equals 1/2 times the quantity of x plus 1 squared. So inside is left or right, the opposite of what it seems. So the plus 1 is going to move it left 1. The number out in front, the 1/2, is either going to make it skinny or wide. If it's between 0 and 1, that's going to make it wide. If it's less than 1, it's going to make it wide. So our vertex would go left 1, and then it's going to make your graph seem wider than what it usually does. So this is an overview of all the transformations. So notice the first one here is a horizontal shift. Notice how your h is inside the parentheses. So if you're adding h, it's going to go left. If you're subtracting h, it's going to go right. So it's the opposite of what it seems like it should be. Vertical, notice how that k is on the outside of the parentheses, and it's exactly what it seems like. So plus k is going to move it up. Subtracting it's going to move it down. A reflection is this flip that we talked about. This negative out here is what causes it to flip. And then this is your skinny or your wide. So this is your skinny if your absolute value is greater than 1. And it's going to be wide if your absolute value is between 0 and 1. So I want you to try these on your own. You don't need to graph. I just want you to look at the equations and tell if they're going left, right, up or down, are they flipping, and are they skinny or wide. So the first one we have g of x equals x cubed minus 3. So this minus 3 is on the outside, which just means that that's going to take that graph and move it down 3. Whereas the next one, this x minus 3, the minus 3 is inside the parentheses, the quantity of x minus 3 cubed. So this one's going to go right 3. If it's inside the parentheses, it's the opposite of what it seems like. H of x equals 1/2 x cubed. So this 1/2 is out in front. So it's the absolute value of 1/2 is between 0 and 1. So that means it's going to make your graph wide. So the next one we have h of x equals negative times the quantity of x minus 2 cubed. So we're going to start with this minus 2 inside the parentheses. So that's going to move it right 2. It's the opposite when you're inside the parentheses. And then we have this negative out in front. So that's like a negative 1. So that negative is going to flip your graph. And then the last one here, we have r of x equals 4 times the quantity of x plus 3 cubed plus 2. So plus 3 inside the parentheses. That moves it left 3. The plus 2 on the outside moves it up 2. And the 4 that's out in front, absolute value of 4 is bigger than 1. So that makes it skinny.